ladies and gentlemen, we ask that you stick with us. We're getting close to the end of the conference. Um, Now we have Dr. Ross Abinet. Will be our next speaker. Give me a second. All right, so we have the honor of having Dr. Mohamed Abdallah with us today. He's an associate professor. He's an associate professor in persistent organic pollutants and emerging contaminants at the University of Birmingham School of Geography, Earth and Environmental Sciences. His research applies advanced mass spectrometry to detect and assess trace heavy metal pollutants in human and environmental samples. With expertise in exposure assessment and pharmacokinetic modeling, he investigates the risk of emerging contaminants and microplastic. Dr. Abdallah is a member of the Birmingham Plastic Network, and he contributes to interdisciplinary efforts aimed at understanding pollutant behavior and advancing sustainable solutions to global plastic and chemical pollution challenges. Dr. Abdallah, absolute pleasure to have you here. Please feel free to share your slide. And thank you for joining us today.
Thank you very much. Do you want me to share my slides from my computer?
Yes, please.
Just
we can.
checking. Okay.
I mean, it's fine. We can use that.
Yeah, I think
that's fine.
I think we can just go on with with the presenter's view, because it's presenting the presenter's slide on my other screen. Anyway,
it's okay.
It's late in the day, and I don't want to keep the people anymore and any longer. So thank you for having me. I'm Professor Mohamed Abdallah from the School of Geography, Earth and Environmental Sciences at the University of Birmingham. I'm here today to present to you our Daphnia-based technology for wastewater treatment. As you can see, this is not just me. I'm fronting a large team of interdisciplinary scientists from different schools and backgrounds, from biosciences, from mechanical engineering, and from chemical engineering, with a large research team of technicians, PhD students, and postdoctoral researchers. The project and the work is also conducted in collaboration with industrial partners and charities, as you can see on the slide, Severn Trent Water and the National Trust. This is a large consortium project that actually includes 22 partners from 11 countries, from academic and non-academic sectors, with a total funding from the European Union of up to 7 million euros and a UK contribution of about 3 million euros. I will not go through all the partners and what they are doing, but I will have links at the last slide for those who are interested to follow the consortium and what we are doing there. But mainly for today, I'm going to present to you our work here at the University of Birmingham in developing a Daphnia-based technology for wastewater treatment. So what's the problem? Well, I'll be very brief about this. The main problem is that pollution poses a massive threat to public health, claiming the lives of 9 million people each year. And part of that, or a big part of this issue, is that according to the United Nations Environmental Programme, 80% of water is contaminated with what we call persistent mobile chemicals. Some people call them forever chemicals. And contrary to common belief, this contamination is actually everywhere. It's not limited to developed countries. This is for both, developed and developing countries. In fact, the contamination with these industrial chemicals and pharmaceuticals and pesticides in developed countries sometimes exceed what the levels in developing countries because of the sources of these chemicals and pollutants. So to address this problem, This was back in 5 years, almost 5 years ago, so 21, 22. In 2022, we published this paper with a concept where we were thinking of developing a treatment, a wastewater treatment solution using Daphnia magna. Now, for those of you who are not familiar with Daphnia magna is commonly known as the water flea. It's a very small crustacean, like as you can see in the image. And what it does is, for those who are not also into biology and science that much, what it does is basically works like a vacuum cleaner for wastewater. It is a filter bottom feeder, so it feeds on everything, it filters everything. But the idea was that these Daphnia can, through being a bottom filter feeder, they can accumulate the bad chemicals in their bodies through bioaccumulation. The other advantages of using Daphnia for this tertiary wastewater-based treatment is that they multiply quickly. They have a transparent body, which will become really useful in monitoring what's happening in the body of the Daphnia, as you will see in a couple of slides. And they are also completely in line with the 3Rs principles in animal testing. So their use is completely sustainable and is completely ethical as well. Through our research, we managed to identify certain genotypes of Daphnia that are more tolerant to chemical pollutants. This means that they are less affected or more resistant to these bad chemicals that exist in the wastewater and that cannot be removed by the traditional wastewater treatment processes. So again, you can see that paper about the time machine, which we published in 2022, highlighting these aspects and why we chose Daphnia in particular for our wastewater-based treatment. Then we move to the next stage, and this is a prototype. I have to say that this is IP protected and we have a patent, so I cannot go into exact details. I'll just explain the main idea of this. So basically what we have is that we have developed through engineering a mesh-shaped cage for Daphnia, which are constantly fed to survive and flourish. And these design cages are lowered down as inserts in the wastewater treatment tanks in a specific geometrical shape that will only allow the water from the inlet to the tank to pass through these cages and be filtered by the Daphnia before they can actually go out of the tank as tertiary treated wastewater. We also have we have monitors for the Daphnia population. We have several sensors in there. There is a technology to prevent biofouling, and we're currently working also on solutions for upcycling of the waste dead Daphnia. So the whole technology becomes a zero waste technology. So I'll come to that in a couple of slides. So just to show you a few of the results, and I will not go into details because there is a lot of results and a lot of data. I just want to address the audience of this forum about sustainability mainly. But what we can see is that we have monitored more than 30 priority chemicals or pollutants in wastewater, and including things like microplastics and forever chemicals, parent polyfluoroalkyl substances. The image you can see here is of one of the Daphnias, and the green stuff you can see there is actually microplastics that we have labeled with a fluorescent dye, so we can see through the transparent body of the Daphnia that they are eating and retaining these microplastics alongside with the other chemicals. Um, the other things that we can report to the forum is that because this is a bio-based solution, nothing obviously is perfect. So we observe a lot of variation in the performance. So while the technology is constantly working on removing these different chemicals and microplastics, the performance varies depending on the specific compound, as well as other factors that we have identified and we are currently working on, including the population density of the Daphnia, the pH of the water, the oxygen, and the temperature. And we also noticed that when there is heavy rain, there is a lot of dilution effects happening. So these are factors that we are currently working to optimize, but nonetheless, there is always a removal of the chemicals and the microplastics being monitored through our prototype. These are other data where it shows that the Daphne are not only removing the emerging contaminant chemicals and microplastics, but they are also removing total phosphorus, total suspended solids, and reducing the chemical oxygen demand in the tanks. So moving on again, addressing this forum about sustainability, one of the aspects that we are monitoring and the studies that we are conducting on our prototype is to do a complete life cycle analysis according to the ISO 14040 and 14044 standards. And this actually involves all the material extraction and manufacturing phases of the prototype itself, and then the prototype processing conditions, and then finally the outputs as well, and the waste that is coming from the operation of that prototype Daphnia based tertiary treatment. So this is work that we have already completed and it's currently under review for publication, but I can share with you some highlights of our results in this respect. So in terms of the prototype performance, this is just to be clear, this is the green part in here. This is the process itself for wastewater treatment. We have monitored several environmental impact indicators, as you can see in this table. These are contributing to key environmental categories, including climate change, resource depletion, eutrophication, land and water use, and freshwater ecotoxicity. So I again, given the diverse audience of this forum, I will not go into these one by one, but what I'm going to say from the results in that table, you can see clearly that the footprint is really low, and the performance in terms of potential for impacting climate change and land and water use and all of these indicators is really, really low. These numbers are really, really low compared to other treatment technologies for the same purpose. So this was really promising and shows the sustainable value of this technology. Now, on the other hand, obviously, as I said, nothing is perfect. And when we conducted this life cycle analysis, we didn't only analyze the operation bit, we also analyzed the material extraction and manufacturing phase. And in this table, using the same parameters in the same framework, so again, we are measuring the indicators for impact on climate change, energy depletion, and all of these factors. You can see that we have identified the processes that contribute most to the environmental footprint of this Daphnia-based technology. And these are the ones that are highlighted in red and orange. So the steel vessels manufacturing and the high-density polyethylene pipe manufacturing. These are contributing most to the impact of our prototype. So we have identified these, and we are aware of them at the moment, and we are taking actions and steps to try and minimize this impact through upcycling and recycling solutions. So overall, to summarize, this Daphnia-based technology provides a scalable and sustainable, low-cost, low-carbon, and retrofittable tertiary water treatment biotechnology for the removal of emerging chemical pollutants, including the parent polyfluoroalkyl substances, the forever chemicals, and the microplastics, which cannot be removed efficiently by existing traditional wastewater treatment technologies. As a controlled or on the controlled prototype scale, the removal efficiencies can go up to 90% for certain chemicals. But as I said, these vary depending on the type of the chemical as well as the other factors, including the population density of the Daphnia. We are working to optimize these conditions at the moment. The life cycle analysis showed that this technology can remove the emerging chemical pollutants and excess nutrients with a negligible carbon footprint, while the material extraction and manufacturing dominate the environmental impacts. So in terms of improvements and future work until the end of the project in 2027, we are currently understanding and optimizing the factors influencing the performance with the aim of achieving maximum optimized performance for all these emerging contaminants that we are looking at. We are also developing and optimizing material recycling at the end of life treatment with the aim of reducing further the environmental impact of this technology. So thank you for listening. I have put the details of the consortium in here with a QR code and some links if you want. Also the website if you are interested to learn more about our work and also the work of our partners with the overall aim of making European rivers and the water in European rivers more clean and sustainable. Thank you very much.
Thank you very much. Very exciting. And thank you very much, Dr. Abdallah, for that wonderful and insightful presentation. If you can please just give us a few minutes to have the last speaker for today, Professor Rogers. Then I'll bring you back in for Q&A session. Thank you very much.